Greetings learners, this is your Sir Brandon and I'm here to present the maximum flow technique. The maximum flow technique seeks to determine the maximum quantity that can go from one node to another in a network at a given time. The objective of the maximal flow problem is to develop a shipping schedule that maximizes the amount of material sent between 2 points. The maximal flow problem is to maximize the amount of flow of items from origin or the source to a destination or sink. This is the case for Siervada Park. Siervada Park, during its peak season, wants to determine how to route the various tram strips or transports from park entrance O, so here's the park entrance, to the Scenic Wonder T to maximize number of trips. There are many combinations of routes need to be considered to find the ones maximizing the number of trips per day. We will use the maximal flow technique to determine the max number of tram trips per day. This is the network for Siervada Park, which is a directed and connected network. So these are the steps in the maximum flow technique. First, we find the path from the source to sink. Then we get the smallest residual capacity of that path and subtract it to the other capacities. And if there's a 0, it means no capacity left. So let's start. So we get iteration number 1. We will find the path from O to T, and the path is O, B, E, T. O, B, E, and T. So we will find the smallest value. So that is 5. Subtract it to itself is 0. 7 minus 5 is 2. And 6 minus 5 is 1. So take note of 5. That is the smallest value. We will list the smallest value. And the path which has 0 is it has no capacity left. We cannot pass that. Okay, number 2 iteration is OA D T. O A D T. We will find the smallest. Subtract it to itself, 0. So we will list 3. 5 minus 3, 2. 9 minus 3, 6. Okay, so number 3 or the third iteration is O A B D T. We will get the smallest. The smallest is 1. Subtract it to itself. 2 minus 1, 1. 4 minus 1, 3. 6 minus 1, 5. So what is the smallest? That is 1. So we cross out. Remember that we cross out the path that has no capacity left. It means that we cannot pass those with 0 values. So we will find another path, and the path is number 4. O B D, T, which is the smallest number, and that is 2. Subtract it to itself, 0. 3 minus 2, 1. And 5 minus 2 is 3. So the path OB is 0. And the smallest is 2. So we cross out that path and we cannot pass that path again. We will find another. So it is iteration number 5. And that is O, C, E, D, and T. In that path, what is the smallest number? The smallest number is 1. 1 minus 1, 0. So we list 1. 3 minus 1. 3 minus 1 is 2. 4 minus 1. 4 minus 1 is 3. 4 minus 1 is 3. So we cross out the path E to D because it has 0 capacity left or no capacity left. So we will have more. Iteration number 6. O, C, E, T. O, C, E, T. What is the smallest number in that path? And that is 1. 1 minus 1, 0. So we list 1. 3 minus 1, 2. 3 minus 1, 2. So I think it is the last iteration. Iteration number 7. For iteration number 7, the last one, that is O, C, B, D, and T. Now, we will get the smallest number, 1. Now, these are the numbers are 5 plus 3 plus 1 plus 2 plus 1 plus 1 plus 1, 14. So therefore, the answer is 14 tram trips per day. Thank you very much, and hope to see you on the next video, and please subscribe to my channel. Goodbye.